I am going to discuss network analysis. Before going into discussion of network analysis, let us first discuss some definitions. The first definition is network. What is network? The network of a project is the graphical representation of project operations or project activities. Now, what about activity? In each network, an activity is shown by an arrow. The arrowhead indicates the direction of progress of activity and the number on the arrow indicates the duration time of the activity. The next is node. The points at which an activity starts or ends are called nodes. These will be shown by circles in a network. Node number denotes an event. Now I will discuss how to draw a network. Now I am going to discuss construction of network. That is how network can be constructed. To construct a network, each network should satisfy the following conditions. Number one is each activity must be represented by one and only one arrow. That is, representation of activity is by one and only one arrow. Second is two activities cannot have same initial and same terminal nodes. That is, each activity must be identified by two distinct nodes. The following graph is not permissible. Like this, here activity A and B have same initial node, that is 1, and same terminal node, that is 2. This is not permissible in the graph. To avoid such type of situations, a dummy activity is introduced between such nodes. The time duration of this dummy activity is 0. Now the question is that when this type of situation occurs, such type of situation occurs when some of the activities are emanating from the same node and preceding the same activity. This situation can be avoided by the addition of dummy activity. Now, this is not permissible in the graph. To avoid the above situation, a dummy activity is introduced between such nodes. The time duration of this dummy activity is 0. Like this is node 1, so this is node 2. The activity from node 1 to node 2 is A and the time duration of this activity is 5. Now, we can add a dummy activity, a dummy node 3 and a dummy activity from 3 to 2 whose duration is 0 and activity 1 to 3 is represented by B and its time duration is 6. Now both the activities A and B have same initial node but the terminal node of both the activities are different. The terminal node of activity A is 2 and the terminal node of activity B is 3. Now this type of situation can be avoided by this by adding of dummy. This can also be done by this. Say this is node 1 and this is node 3 and this is node 2. Say activity from 1 to 2 is A and its time duration is 5 and 3 to 2 is activity B and its time duration is 6 and 1 to 3 is dummy activity whose time duration is 0. Now in this case the activities A and B have different initial nodes but the same terminal node. The both that same initial and same terminal nodes can't be allowed in a graph. If such type of situation occurs, then we can avoid it dummy by adding dummy activity like I did in this case. Either you difference its terminal point or you different its initial point. Third is arrows should not form closed loop. That is, this is not permissible in the graph. Like this, activity A is from node 1 to node 2 and its time duration is 6. Say here node 3 and activity B from node 1 to node 3, its time duration is 5. Sorry, activity B is from 3 to 1 and its time duration is 5, and activity C from node 2 to 3 with time duration 4. Now this forms closed loop from 1 to 2, 2 to 3, 3 to 1. This should not be permissible in the graph. Arrows should not form closed loop. The fourth is starting and ending nodes should be unique. That is, there is one starting node and one ending node. The following graph is not permissible. That is like this. Here starting nodes are 2. That is not unique. Here ending nodes are also 2. That is not unique. That means this is not permissible in the graph. Always there is one starting node and one ending node. That is, starting and ending node should be unique. The fifth is very important point: to maintain the exact precedence relationship. We must note that what activities must immediately precede the current activity. Number 2, what activities must follow the current activity. Number 3, what activities must occur concurrently with the current activities. This, the point 5, I can explain with the example. Suppose we have in a network, we have given activity capital C can start immediately after activity capital A and activity capital B are completed. Number 2, activity capital E can start immediately after only activity B is completed. Now someone can draw like this. Say activity C can start immediately after A and B are completed. Say activity A and activity B can complete here. Now activity C can start immediately. After this, C can start. Activity E can start immediately after only activity B is completed. Now one can draw like this. This is wrong. This is not permissible in the graph, because concentrate on the second point. This gives activity E can start immediately after only activity B is completed. Here we get from this that it requires that activity A and B must be completed before E start. But here activity E can start immediately after only activity B is completed. To avoid such type of situation, yeah, or to maintain exact precedence relation, we introduce dummy activity like this. Say activity A is completed and activity B is completed. Here at this node activity A is complete, and from this node activity B is also complete at this node. Now after A and B completed, activity C can start immediately. From here we can start activity C. Now activity E can start immediately after only activity B is completed. Here at this node only activity B is completed. Therefore we can start activity E here. Thus fifth point is very much important, as I explained with this example that this is not permissible in the graph. If such type of situation occurs, then you can avoid it by adding dummy activity like this. The important remark in accordance to point number 5 is when some activity precedes two or more activities with different different nodes, the precedence relationship is maintained by introducing dummy one or more activities to connect these different nodes. Now I am going to discuss construction of network with the help of an example. Here, consider this example. Construct a network where activities satisfy the following requirements. The first requirement is activity capital A and activity capital B are the first activities of the project to be start simultaneously. Number two is activity capital A and activity capital B precede activity capital C. Number three is activity capital B precedes activity capital D and activity capital E. Number four, activity capital A and capital B precede activity capital F. Number five, activity capital F and activity capital D precede activities capital G and capital H. Number 6, activities capital C and capital G precede activity capital I. Number 7, E, capital H and I are the terminal activities. The duration of these activities A, B, C, D, E, F, G, H and I are given as 2, 3, 5, 2, 7, 4, 6, 11 and 3 respectively. Now, one thing is important that you have to draw the network with the help of pencil and not with pen. Once you finalized your network by pencil, then make it permanent with pen. Now I am going to draw the network. The first is activity capital A and capital B are the first activities of the project to be start simultaneously. Say here note activity capital A and capital B start simultaneously. Second is activity capital A and capital B precede capital C. Say these activities end here and activity capital C starts from here. The point 3 is activity capital B precedes activity capital D and capital E. The activity capital B precedes activity capital D and capital E. Now, if we make graph like this, then our rule number 2 and 5 is violated. Our rule number 2 and 5 is violated. Why so? The rule second says that two activities can't have same initial and same terminal nodes. Here activity A and activity B have same initial and same terminal nodes. If this type of situation occurs, then we avoid it with the introduction of dummy activity. And if we go like this, then the rule 5 is also violated. Why so? Because here activity B precedes D and E, but not activity A. But here information comes that activity D and E, that activity A and B precedes activity D and E. Therefore, the maintain of exact precedence relation is disturbed. To maintain exact precedence relationship, we follow as now. Since this is not permissible in the graph, let we reconstruct our network. Here number 1 is activity capital A and capital B are the first activities of the project to be start simultaneously. Say activity capital A and activity capital B start simultaneously. And now A and B precede C. To make this, we add a dummy activity here. This is our dummy activity. Now A and B precede C. Here A complete, through this B is also complete here. Therefore activity A and B precede activity C. Now the third point is the activity B precedes D and E. Let here activity E starts because B completed here. Therefore from here activity D and E starts by point number 3. Here activity E starts, here activity D starts. Now fourth point is A and B precede F. That means A complete here, B by through this complete here, and then activity F starts here. Say we start activity F here. Now 5 point is activity F and D precede activity G and H. Activity F and D. Now how can we complete this activity F and D? If we erase this, say this is our activity D and this is our activity E. Now fifth point is activity F and D precedes G and H. Say here activity F and D complete, and by this their initial nodes are different and their terminal node is same. Here activity G and H starts here. Say G and H starts here. The sixth point is activity C and G precede I. Now how I can make C and G? To make this, we can erase G here and H here. Activity C and G precede I. Now say activity C and G complete here and activity I starts from here. And further activity E, H, I are the terminal nodes. Now we cannot end graph like this. If we end a graph like this, then our fourth point is violated. That fourth point is that starting and ending nodes should be unique. Here starting node is unique, but there are 3 ending nodes. Our fourth point is that starting and ending nodes should be unique. Here starting node is unique, but 3 ending nodes are there. Therefore this is not permissible in the graph. We have only one ending node, that is ending node is unique. To complete this graph like this, here C and G completes and I starts. Say I activity is here and H activity is this. To complete I, here E activity is, this is E activity. Now we will complete these 3 activities and ending node is unique. Now this is our graph, or this is our network which follows all the rules. Now we can write duration of these activities. Duration of activity A is 2, duration of activity B is 3, duration of dummy activity is 0, duration of C activity is 5. Duration of D activity is 2. Duration of E activity is 7. Duration of F activity is 4. Duration of G activity is 6. Duration of H activity is 11. And duration of I activity is 3. Now we can numbering the nodes, say 1, 2, 3, 4, 5 and 6. Now this is our complete network. Like this you can draw the networks with the help of rules as I have discussed earlier. The important thing is that you have to make network first with pencil, and after your graph is finalized, then make it permanent with the help of pen.
फ्रेंड्स, अगर आपको हमारा ये मेथड अच्छा लगा तो प्लीज़ हमारे इस चैनल को सब्सक्राइब कीजिए। वीडियो के नीचे जो बेल आइकन का बटन है उसे प्रेस कीजिए, जिससे आपको हमारी न्यू वीडियोस की नोटिफिकेशन मिलती रहेगी। थैंक यू फ्रेंड्स, कीप वॉचिंग आवर वीडियोस।